As the sun descends and the moon ascends, the vibrant blue sky gradually dissipates, revealing the vast expanse of space. It's a nightly wonder, and one can't help but marvel at our incredible fortune to witness this phenomenon. But have you ever wondered why this transition occurs? Why does the serene blue veil give way to unveil the cosmic unknown, as if someone were drawing a curtain to reveal the secrets of the universe? In this episode, we delve into the enigmatic darkness of space, despite it being adorned with countless gleaming stars. We ponder the question, why does the cosmos appear so profoundly dark? This is Reveal the Mystery. If you're curious to learn mysteries of the world, space and beyond, consider subscribing. When we gaze into the night sky, two prominent features capture our attention: an abundance of stars and an immense expanse of pure, unbroken darkness. This observation, of course, applies predominantly to those who dwell in areas remote from city lights, as urban living may only afford a fortunate few a glimpse of a dozen stars on a clear night. However, it is widely acknowledged that the cosmos harbors an apparently boundless multitude of stars, each radiating with extraordinary luminosity. To put this into perspective, even our own sun, positioned a staggering 93 million miles away, generously bathes our planet in its radiant glow. Given that our sun, along with other stars throughout the universe, emits copious amounts of light, one might naturally question why the void of space itself remains shrouded in perpetual darkness. If you've pondered this enigma and arrived at the notion that space, being a vacuum bereft of substantial gases, lacks the means for light to scatter or reflect off particles, you are not entirely mistaken. While this is a valid point, it does not unveil the complete answer. To unravel the intricacies of this cosmic puzzle, we must delve into the concepts of surface brightness, a pivotal term in the realm of astrophysics, and acquaint ourselves with the inquisitive mind of Heinrich Olbers. Back in 1823, when the prevailing belief held that the universe was both infinite and static, the cosmos was perceived as an unending expanse that remained immobile. At this juncture, the expansion of the universe was yet unknown. Heinrich Olbers, the German astronomer, wrestled with this very quandary during this era. His profound insight revealed a fundamental principle: the surface brightness of a star remained consistent, regardless of the star's distance from us. In practical terms, if we were to trace a direct line from a specific point on the surface of our sun, that point would shine with the same brilliance, even if our sun were positioned tenfold farther from us. Armed with this knowledge about surface brightness and considering Olbers' assumptions about the universe, we confront the crux of the matter. In a universe conceived as infinite and static, as Olbers had postulated, it would be conceivable to peer in any direction and, given sufficient time, stumble upon a point of luminosity, an inexhaustible array of stars scattered throughout the cosmos. Consequently, the night sky should be resplendent with a brilliance rivaling the surface of a star, filling the darkness with boundless radiance. Yet, the reality does not align with this expectation. This enigma, known as Olas Paradox, underscores the discrepancy between Olbers' theoretical musings about the universe and the empirical observations that have since illuminated our understanding of the cosmos. Remarkably, during that era, the sole individual to provide the most plausible scientific explanation was none other than Edgar Allan Poe, the celebrated poet known for his dark and haunting verses. Surprisingly, Poe, although predominantly recognized for his morose and brilliant poetry, harbored the belief that his enduring legacy would rest upon his scientific insights rather than his literary creations. Following the tragic loss of his wife, he delved headlong into the realm of physics to compose his 10th and final work, Eureka. Within the pages of this unconventional treatise, he put forth the notion that the universe, given its infinite expanse, had not yet existed for a duration sufficient to permit the full illumination of the night sky. Though Eureka contained its fair share of scientific inaccuracies, the fundamental concepts surrounding Poe's ideas were astonishingly close to accuracy. Even more astonishing, tucked within Eureka, Poe articulated a theory positing that the universe had originated from the detonation of a solitary primordial particle. Unbeknownst to him at the time, he had, in essence, correctly prophesied the Big Bang theory nearly a century ahead of its formal discovery. While Edgar Allan Poe ultimately gained prominence for his literary brilliance, he did achieve his wish, as many now remember him for his prescient ideas concerning the Big Bang, an acknowledgement of his scientific acumen and his proximity to resolving Olbers' paradox, an issue that was eventually unraveled by a name likely familiar to you. The person who successfully addressed Olbers' paradox was none other than Edwin Hubble. In the 1920s, Hubble made the groundbreaking revelation that entire galaxies were receding from our vantage point. However, it was not solely the galaxies in motion, rather, it was space itself that underwent expansion. Hubble made this discovery by detecting the shift of wavelengths of light emanating from galaxies and stars over time as they gradually extended into the infrared spectrum. This phenomenon became known as redshift, signifying that as light waves expanded, their brilliance waned until they became imperceptible within the visible spectrum. Hubble also observed that galaxies nearer to us did not exhibit the same rapid retreat as those positioned farther away. In an astonishing revelation, he discerned that space was not only expanding, but doing so at an accelerating rate the farther one peered into the cosmic abyss. This observation, through meticulous measurements, enabled the determination of the age of the light reaching us. A renowned example of this concept is the Hubble Extreme Deep Field photograph. With this shift in the cosmic model, transitioning from a static universe to an expanding one, the enigma of Olbers' paradox was resolved. It became evident that space expanded at a pace exceeding the speed at which light could maintain its wavelength within the visible spectrum. In essence, it was not that light had not reached us due to the expansion of the universe. Rather, it was the finite speed of light that played a role. As space expanded, it stretched the wavelengths of light further into the infrared spectrum, thus diluting the light within our visible spectrum before it could reach us. This explains why space appears black, not due to the absence of light, but because the universe's expansion outpaces the capacity of light to reach us. It is imperative to grasp that while objects cannot traverse space at velocities surpassing the speed of light, space itself is unrestricted by this constraint, adhering to its own rules and dynamics. The exploration of cosmic mysteries often initiates with the simplest of inquiries. Questions such as why apples fall from trees, why planets orbit stars, the age of the universe, and the origin of the night sky's darkness can unexpectedly lead to profound revelations. For example, consider Hubble's groundbreaking revelation, which laid the foundation for the emergence of the Big Bang theory, presented around a decade later. It logically followed Hubble's discoveries. If space expands and its expansion accelerates, rewinding the cosmic clock suggests that the universe was once much smaller, denser, intensely hot, and brilliantly radiant. 3 decades later in New Jersey, a pair of radio astronomers stumbled upon cosmic microwave background radiation, a remnant signature of heat from the Big Bang. All these breakthroughs contribute to our current understanding of the universe's earliest moments and its ongoing evolution. These profound insights all trace back to seemingly unassuming questions, the kind you might have today. Therefore, I encourage you to pose them, diligently pursue the evidence, and steadfastly follow it to the answer, no matter the cost. You never know when your seemingly simple question might be one of the most monumental discoveries in human history.